Lesson 20. A couple of things to remember. The square root of a negative number is not real. However, we're going to define in this lesson that the square root of -1 is going to be I. The letter I. It's one of the few letters in algebra that is reserved for a special meaning. It means the square root of -1. That will allow us to go ahead and take the square root of these negative numbers. So if I want to do number 1, the square root of -96, I'm going to rewrite this as -1 times 16 times 6, because 16 is a perfect square that will divide into 96. Now the -1 is going to be designated with I, and the square root of 16 is 4, and then the square root of 6 has to stay inside. Now customarily we would put the number in front, so I would write this 4i times the square root of 6. So anytime you have a negative under a square root, you're going to have an I in your answer. Now the rules for multiplication and division are different when you're dealing with imaginary numbers. I is called the imaginary unit, and the operational rules are a little bit different. So if you have a negative square root, let me do one that's not on the paper. -2 times -6. I can't just multiply those together because that'll just come out to a regular positive number. So instead, what I want to do is write this I times the square root of 2 times I times the square root of 6. Now I can't do anything to that 6 yet, but I can write this now, I squared times the square root of 12. Now one thing we need to remember is that since the square root of -1 is I, we now know that I squared has to be -1. So instead of this I squared, I need to write a -1, and now I'm going to reduce. 12 is 4 times 3. So that's going to be -1 times 2 times the square root of 3, or -2 square root of 3. So remember, anytime you do an operation with a non-real number, you need to reduce the I part first. In number 2, it doesn't really matter so much in this one, I square root of 30 over I square root of 3, because that's going to end up being the square root of 10, because I divided by I, just like any number, is 1. Square root of 30 divided by the square root of 3 is square root of 10. That if this had been multiplication, it would have been a different story. So part 2 of number 2, -5, the square root, times the square root of 20, is I square root of 5 times the square root of 20. So that's I times the square root of 100. Well, that's just 10I. So keeping in mind the square root of -1 is I, and I squared is -1. These are the two facts you're going to want to remember about imaginary numbers. Now when we're adding and subtracting these imaginary numbers, like in number 3, the rules are basically the same as adding and subtracting like terms. So here I've got negative 5 plus 4i, and I've got this minus sign that I need to apply to both of those, so that's going to be plus 3 minus 2i. And then negative 5 plus 3 is negative 2, and 4 plus, plus 4i minus 2i is plus 2i. Now when we write our imaginary numbers, we put the I in the back usually, and we write this in what we call complex form, a plus bi. And that's because a is a real number and b is an imaginary number, and together we call that a complex number. And we want to write the real number first when we see that. So now remember, the square root of negative 1 is I squared is negative 1, and our complex form is a plus bi. In number 4, you've got multiplication. Now multiplication and division are different than addition and subtraction. You've got to watch out when you're multiplying and dividing imaginary or complex numbers. It's still the full rule, so I'm going to get 30 minus 30i minus 12i plus 12i squared. So that's going to be 30 minus 42i plus 12 times negative 1, because I squared equals negative 1 is one of the facts we have to remember. And 30 plus negative 12, because that's going to be minus 12 there, is going to give me 18 minus 42i. So the real number's in the front and the imaginary number is in the back. That's our best format. And that's the answer to number 4. Now the main reason we need imaginary numbers is because we know that when you have an x squared in an equation, that this exponent tells you that there are two solutions. So every time we have an x squared in an equation, we're looking for two answers. For example, in v squared equals 81, that's a square, so I'm going to set it equal to 0. And I'm going to factor it, v plus 9, v minus 9, to solve it. So that gives me v plus 9 equals 0, and v minus 9 equals 0. So I do in fact find two answers. V is minus 9, and v is plus 9. Now there's actually a shortcut for this called the square root property. And what the square root property says, if you have x squared equal to a number, then x is the plus and minus square root of the number. But it has to be a number. It can't be a variable over here. So instead of having to factor v squared equals 81, I can say v equals the plus and minus square root of 81. Well, that gives me v is plus and minus 9. So I got the same answer that I got up here when I did it by factoring. And again, the square root property, that's what this is called, the square root property. That only works when you have a square equal to a number. So since this was a regular number here, and it can be positive or negative, but it has to be a number, it can't have a variable, then whatever is squared, v here, is plus and minus the square root of that number. So number 6, x squared equals 75. I don't need to move that over and factor. I do know that I'm looking for two answers. I can say that x is the plus and minus square root of 75. So I can reduce this. 75 is 25 times 3, and the 5 can come out. Be careful, it goes after the plus minus. So x is negative 5 square root of 3 and positive 5 square root of 3. So there are two answers for x, the negative 5 square root of 3 and the positive 5 square root of 3. Now I want to do one more that's not on your sheet. If I had x squared equals negative 9, and I move that over, x squared plus 9 equals 0, that would be prime, and I would not be able to solve it. But because I have the square root property now, x squared equals minus 9, then I know that x is equal to the plus and minus square root of negative 9. That's my square root property. Now I'm going to say, well, that's negative 1 times 9, so the square root of that is going to be I times 3, or plus and minus 3i. So there are two answers to this problem that was not on our sheet, x squared equals negative 9. It's negative 3i and positive 3i. Number 7. You may have a square that involves an operation. So because I have this x minus 10 squared and this minus 20 as a number, I'm not going to bother to full that out. I'm going to leave that x minus 10 quantity squared, and I'm going to move my 20 to the other side. And because I have something squared equal to a number, I can say that that expression being squared is the plus and minus square root of 20. So I don't have to full that out. Now I move my 10 to the other side. This time it goes in front of the plus and minus. So x is equal to 10 plus and minus the square root of 20. There's a perfect square of 4 in there, so I have to bring that 4 out by taking its square root. 10 plus and minus 2 square roots of 5. So there are two answers. 10 minus 2 square roots of 5, 10 plus 2 square roots of 5. Then we have a dilemma. We might come across something like this: x squared plus 4x plus 2 equals 0. So this is another example that is not on your worksheet. My problem with this is that this is a prime polynomial. There are no factors of 2 that will give me a 4. And if I move the 2 to the other side, I don't have a square here. I've got this 4x that's going to give me trouble. If I move it to the other side, then I don't have a number on the right-hand side. So this is a prime polynomial that won't factor, that I cannot use the square root property on. So for this, I do want to use what is called the quadratic formula. And what's nice about the quadratic formula is that it works for all quadratic equations. Whenever you have ax squared plus bx plus c equal to 0, you can use the quadratic formula. And this is what it says: x is equal to the opposite of b plus and minus the square root of b squared minus 4ac, and then all of that is divided by 2 times a. So all we have to do is get it in this format and then use this formula. So for number 8, this one I believe might factor. Let's see, 7 times 2 is 14. No, it won't. There are no factors of 14 or negative 14 that will add up to 3. So I have to use the quadratic formula. So A is 7, B is 3, and C is negative 2. Now, even if it would factor, you could use the quadratic formula now. So x is equal to the opposite of b plus and minus the square root. B squared is always going to be positive, and I'm just going to go ahead and put that 9 in there. So no matter what b is, go ahead and square it and then write it there. It's going to be positive because you're squaring it. Minus 4 times a times c, that's minus 4 times 7 times negative 2, all over 2 times 7. That's 2 times a. So that means x is negative 3 plus and minus the square root. And now I need to do the arithmetic that's inside. And I recommend you just type it in your calculator just like you see it there. So if you've got a scientific calculator, you can just type it in. 9 minus 4 times 7 times negative 2 is 65. Just type it in your calculator. All of that is over 14. Now, if this root will reduce, you have to reduce it. But there are no factors of 65 that are perfect squares, because 65 is 5 times 13 and 1 times 65. And none of those, except for 1, are perfect squares. So you have to see if it will reduce. Now, make sure that this bar is completely underneath. Your 2 times a belongs to both of these. Number 9, 2x squared minus 7x equals negative 1. Well, this has to be equal to 0 first, so I need to add 1 and bring that over. So a is 2, b is negative 7, and c is 1. And in the quadratic formula, that will be x is equal to, the opposite of b would be 7, plus and minus the square root. Negative 7 times negative 7 is 49, minus 4 times a times c, and all of that is over 2 times 2. So that's going to be 7 plus and minus the square root of 41 over 4. And again, we need to look at this square root, this radicand, to see if it will reduce, but the square root of 41 will not reduce because 41 doesn't have any square factors. Number 10. Find all complex solutions of 4x squared minus 5x plus 2 equals 0. So they're giving us a little bit of a hint in the instructions that we're going to have an I in our answer. X is equal to the opposite of b, since it's negative 5, I'm going to put a 5, plus and minus square root of 25, that's b squared, minus 4 times 4 times 2, that's 4ac, all over 2 times 4. So that's 5 plus and minus the square root. Well, this is 25 minus 32. So if you do this arithmetic, 4 times 4 is 16 times 2 is 32, and 25 minus 32 is negative 7 over 8. And because we have the square root of a negative, we need to bring out the I, square root of 7, and all of that is over 8. So our final answer is 5 plus or minus I, square root of 7 over 8. And I'm going to do a separate video for the applications.